Let's be honest. AI kind of feels like magic these days, right? I mean, you ask it for an image and bam, there it is, a perfect painting in seconds. You throw a super complex question at it and it just spits out this beautifully written answer. It almost feels like it's thinking, like it's creating, like it actually gets it. But what's really going on behind that magician's curtain? You know, the source material we're digging into today shows us that it's not some little genius in a box or a brain floating in a jar. Nope, it's something way more fundamental and honestly, way more powerful. So let's pull back that curtain. Okay, so this image from our source just nails the myth, right? On the left, under myth, that's French for myth, you can see how we talk about AI. We say it understands, it reflects, it has intuition. This is the big show, the performance. But then, on the right, you get this little peek at the réalité mathématique, the mathematical reality. And that's what we're about to unpack. Because, yeah, behind that curtain, it's a completely different story. It's not magic, it's not some deep mystery, and it's definitely not consciousness. It's just math. Pure, incredibly powerful, and really, really clever math. This right here gets to the absolute heart of it. Our source material puts it so bluntly. AI is not a conscience, it's an optimization. Think about that. Every single algorithm, no matter how much it blows your mind, is just a giant cascading waterfall of math problems, all designed to do one thing: get better at a task. So this is the key distinction we have to make. When we feel like AI understands meaning, what's actually happening under the hood is it's just tweaking millions of numbers to make an error smaller. And when we think it has intuition, nope, it's just calculating the odds, figuring out the most likely pattern. It's a total shift from thinking about feeling to thinking about function. And this visual from the source, oh, it's just perfect. It shows the mechanical heart of this whole thing so well. On the left, you've got perception humaine, our human perception, the illusion of a thinking machine. But look to the right, réalité algorithmique, the algorithmic reality. It's just a grid of numbers getting adjusted. And that U-shaped graph at the bottom, labeled learning, that says it all. The entire goal is to find the lowest point on that curve. That's it. That's mathematical minimization. You know, this whole idea of machine learning is maybe the most misleading term in all of tech. For a machine, it's a completely mechanical process. Just imagine you're training an AI to recognize a cat. The first time, it's just a jumble of random numbers. You show it a picture of a cat and it says potato. Okay, so the system gets told, nope, wrong. And right then, an algorithm goes back and just nudges millions of tiny numbers, just a little bit, so that the next time the answer is a tiny, tiny bit less potato and a tiny, tiny bit more cat. Now do that a few million or billion times. That's machine learning. So how does this incredible dance of numbers actually work? Well, the source tells us it all comes down to 3 core mathematical pillars. This is the engine room of AI. This slide gives us a fantastic visual anchor for it all. Right there in the center, you can see what the source material calls les piliers de l'apprentissage machine, the pillars of machine learning. And what are they? Probabilities, linear algebra, and statistics. Okay, pillar 1, probabilities. Here's the thing. An AI never actually knows anything for sure. It's all about likelihoods. It doesn't see a cat. It calculates that, based on all the patterns it's seen before, there's a 98% probability that those pixels form a cat. It's basically a machine for quantifying uncertainty. Next up, linear algebra. I know, it sounds super intimidating, but the core idea is actually pretty simple. To an AI, a picture is just a giant spreadsheet of numbers, right? One for every pixel. Linear algebra is the magic toolbox that lets the machine treat that entire grid of numbers as one single thing. So rotating an image, finding the edges, that's all just one neat operation. It's the language that lets an AI see in the first place. And finally, statistics. This is the science of finding the signal in all the noise. Statistics is what lets an AI sift through mountains of, say, medical data and go, looks like there's a statistical link between this marker and this disease. The machine has zero clue about biology, but it spotted a pattern that might be totally invisible to the human eye. Which brings us to that term neural network. Man, that biological name is such a seductive trap, isn't it? But as our source makes really clear, it is not a brain. A much better way to think about it is like a giant factory. Data comes in one end, goes down an assembly line of equations, the results get passed to the next line of equations, and on until a final answer pops out the other side. It's an assembly line for math. Now, understanding this mathematical core, it isn't just for academics. It's actually a huge deal. It creates this critical strategic divide in how we all interact with this tech. It's what separates the people who just use AI from the people who can truly build with it. And this slide just lays out that divide perfectly. Math is le pont mathématique, the mathematical bridge. On one side of the bridge, you've got the utilisateurs dépendants, the dependent users who are basically using black box tools they don't understand. And on the other side, the créateurs optimisateurs, the creators and optimizers who have all the control, all the power to innovate because they get the fundamentals. And the differences are, well, they're stark. The user, they're dependent. They have very limited control, and they're totally exposed to hidden biases or technical problems they can't even see. But the creator, they have what's called technological sovereignty. They can innovate, they can build custom solutions, and they can create systems they can actually trust because they understand the blueprint. And this isn't just theoretical. It has a massive business impact. Just look at these graphs from the source. The one on the left shows return on investment, or ROI. That green line, the creator, the creator, it shows exponential growth. The red line for the utilisateur, the user, it flattens out, it plateaus. Meanwhile, the graph on the right shows technical debt, basically the future cost of rework. It just piles up and up for the user, while the creator keeps it under control. See? Mastery really does pay off. Okay, so if machines are becoming these undisputed champs of calculation and optimization, what's left for us? Where do we fit in? What's our value in this new world? And this brings us to the final, really powerful metaphor from our source material. Mathematics isn't just the engine inside AI, it's also the bridge that connects that artificial intelligence to our very own, very human, natural intelligence. And our role? It's defined by this one perfect sentence. Machines calculate, humans provide meaning. That's it. That's the fundamental division of labor. An AI can find the needle in a cosmic haystack of data, but it has no idea why it's looking for the needle, or what to even do with the needle once it finds it. That's where we come in. We bring the context, the purpose, the interpretation, and the curiosity. Think about a doctor using an AI to look at a medical scan. The AI might spot an anomaly with superhuman accuracy. That's the what. But it's the human doctor who has to interpret that finding, who has to communicate it to a patient with empathy and compassion, and who ultimately decides on the best path forward. That's the so what. So when you boil it all down, demystifying AI isn't about making it seem less impressive. It's about understanding it so we can steer it. The real magic isn't in some machine that thinks. The magic is in the human ingenuity that created a language, mathematics, powerful enough to get these incredible results. Which really leaves us with one final big question. If the structure of this bridge is math, but the direction is all human, as the architects, where are we going to choose to build it to?